Hello everybody, I'm Suman Matthews and today we will be discussing the topic on differentiation, how to start differentiating for a newcomer. This is a part of grade 11 maths and it is also useful for the NATA eligibility test for architecture. This channel has videos for grades 11, 12, engineering maths and the GRE quantitative section. So do consider subscribing to my channel for more videos and hit the bell so you get notifications each time a new video is published. In this video, we learned the basic definition of differentiation, the basic formulae used in differentiation including trigonometric formulae, and the product and quotient rule. So a function f is said to be derivable at a if limit as h tending to 0 f of a plus h minus fa by h exists. And if this limit exists, it is called the derivative of f at a denoted by f dash a. So f dash a is limit as h tending to 0 f of a plus h minus fa by h. We also denote f dash a by d dx of fx. So d dx of fx is derivative of f with respect to x. We come through some basic formulae. D dx of x raised to n is n x raised to n minus 1 where n is any rational number. Derivative of a constant is 0. D dx of x is 1. Again applying the same formula, d dx of 1 by x will be minus 1 by x squared. Derivative of fx plus gx is derivative of fx plus derivative of gx. Derivative of fx minus gx is derivative of fx minus derivative of gx. Derivative of a constant times fx, you can take out the constant, so it is c into derivative of fx. Coming to question 1, find the derivative of 4 root x minus 2 with respect to x. So 4 root x minus 2, derivative of that will be d dx of 4 root x minus d dx of 2. Derivative of 2 is 0, being a constant. You can take out the 4, so it is 4 into d dx of root x, that is half x raised to minus half. So this becomes 2 by x raised to half. Coming to the second problem, differentiate x minus 1 by x the whole squared with respect to x. So you can write x minus 1 by x the whole squared as x squared minus 2 plus 1 by x squared. So we find the derivative of that is derivative of x squared minus derivative of 2 plus derivative of 1 by x squared becomes x raised to minus 2. Derivative of 2 is 0. So this is 2x minus 2. Derivative of x raised to minus 2, applying the formula, it is minus 2x raised to minus 3. So your final answer is 2x minus 2 by x cubed. Practice along with me. Take a paper and pen and work with me. Find the derivative of x plus 1 by x with respect to x. You can write this as 1 plus 1 by x. When you divide by x, this becomes 1 plus 1 by x. So derivative of 1 plus 1 by x is derivative of 1 plus d dx of 1 by x. Derivative of 1 is 0 and d dx of 1 by x is minus 1 by x squared, which is your answer. Coming to trigonometric formulae, d dx of sin x is cos x, d dx of cos x is minus sin x, derivative of tan x is secant squared x, d dx of cot x is minus cos x squared x, derivative of sec x is sec x tan x, and d dx of cosec x is minus cosec x cot x. Coming to question 3, differentiate 4 sin x minus 3 cos x plus x with respect to x. So this becomes derivative of the whole thing. So taking out the 4, it is 4 times d dx of sin x minus 3 times d dx of cos x plus d dx of x. That is 4 times derivative of sin x is cos x, derivative of cos x is minus sin x, so I get plus 3 sin x plus 1. Coming to question 4, differentiate 3 cot x minus 5 cosec x plus 7 with respect to x. So you can take out the 3, so it is 3 into d dx of cot x minus 5 into d dx of cosec x plus derivative of 7. That is minus 3 cosec squared x, derivative of cosec x is minus cosec x cot x, so it becomes plus 5 cosec x cot x. Next we come to the product rule. If u and v are two functions, derivative of uv will be uv dash plus vu dash. Next, differentiate sin x cos x with respect to x. So that will be sin x into derivative of cos x plus cos x into derivative of sin x. Derivative of cos x is minus sin x, derivative of sin x is cos x, so you get cos squared x minus sin squared x, which is cos 2x. Next, differentiate x plus cos x into x minus tan x with respect to x. So applying the product rule, it is x plus cos x d dx of x minus tan x plus x minus tan x d dx of x plus cos x. That is x plus cos x d dx of x is 1 minus what is derivative of tan x secant squared x plus x minus tan x into what is derivative of x 1 and what is derivative of cos x minus sin x. Next we come to the quotient rule. If u and v are two functions, u by v, derivative of u by v. So your denominator is v squared, numerator is vu dash minus uv dash. Next question 6. Differentiate cos x by 1 plus sin x with respect to x. So what are we using here? The quotient rule. So your denominator is 1 plus sin x the whole squared. Then vu dash 1 plus sin x into derivative of cos x minus uv dash cos x into derivative of 1 plus sin x. That will be your denominator remains 1 plus sin x the whole squared. 1 plus sin x, what is derivative of cos x minus sin x, minus cos x, what is d dx of 1, 0, plus d dx of sin x is what? Cos x. So simplifying, we get 1 minus sin squared x minus cos squared x by 1 plus sin x the whole squared. What happens when we take out the minus sign? We get 1 minus bracket sin squared x plus cos squared x by 1 plus sin x the whole squared. And what is sin squared x plus cos squared x? 1. So your answer becomes 0. Coming to the next question, differentiate sec x minus 1 by sec x plus 1 with respect to x. You can either simplify it or what can we use? The quotient rule. So if I apply the quotient rule, your denominator is sec x plus 1 the whole squared. Then I have v sec x plus 1 into d dx of u, which is sec x minus 1, minus u sec x minus 1 into d dx of v, which is sec x plus 1. That is sec x plus 1 the whole squared. Numerator is sec x plus 1. What is derivative of sec x tan x, and what is derivative of 1? 0. And the same thing applies here. Minus sec x minus 1 into sec x tan x. Simplifying, your denominator remains sec x plus 1 the whole squared. Opening this bracket, we get secant squared x tan x plus sec x tan x minus secant squared x tan x plus sec x tan x. So what gets cancelled? Secant squared x tan x. And this becomes 2 sec x tan x by sec x plus 1 the whole squared. So what have we learned? How to differentiate simple algebraic and trigonometric functions and the product rule and the quotient rule. So what do you do next? Consider subscribing to my channel or visit my page, or you can visit my playlist on NATA Maths or Calculus or Grade 11 Maths. I would love to hear your feedback. Thank you.